So welcome to the video lecture series on theory of computation, and today's video lecture will be taking up an regular expression and we'll just convert to that an NFA, and in turn we'll be converting to DFA. Now the problem is I want to just convert the regular expression called as A plus B whole star. Okay. So this is the regular expression which I want to make it as a NFA, and then you are supposed to just convert to a DFA. So I said that when you use plus over here, it means that you have to take two different parts. So the language which can be generated here is you will get epsilon, and you will get A, you can get B, you can get AA, you can get BB, you can get AB or BA, BBA, so on and so forth. Okay, so this is the language which can be generated. So first we will construct an NFA for this. So I have to take up two different parts. Say for example Q1, and then I just use Q2, Q3, and I just make Q4, Q5, and just Q6. Okay, so let us make this Q6 as a final state. So the topmost path actually I use for A, so I just make epsilon here, and if I go A here and I just use epsilon, so this path is meant for generating A, whereas this path epsilon I just B and I just use epsilon here. So this path is actually used to generate B here. Okay. Now when you take up this one, actually it merely generates A and B, but epsilon cannot be generated. What is epsilon cannot be generated? If I give epsilon in Q1, then it should reach Q6, then only it is getting accepted, because the language which is generated here, epsilon should also get accepted. So when I give epsilon in Q1, if I take this path, definitely A will be there. If I take this path, definitely B will be there. Okay, but you should generate an alternative path. So from Q1 to Q6, I generate epsilon here. Okay. So now three possibilities are there. Epsilon can be generated, A and B can be generated, but this A and B can be repeated any number of times. So both has to be repeated. Okay. So either you can repeat A or B, or together you can repeat it. So in that case, final state is Q6. So I just make a loop back from Q6 to Q1. Just make epsilon. Okay. So this will actually repeat A any number of times and B any number of times, so on and so forth. So this is an NFA diagram for the regular expression called as A plus B star. Okay. Now we have to convert this into an equivalent DFA. So what is the problem here? So when you want to convert an NFA, so this is actually NFA with epsilon, isn't it? So when I use A plus B whole star, epsilon is getting generated, so definitely you have to apply the technique of NFA with epsilon to DFA. Now what should I do? So use epsilon closure. So epsilon closure, find the initial state. The initial state is Q1. So epsilon closure for Q1 is actually Q1, Q2, Q4 and Q6. So Q1, Q2, Q4 and Q6. So just name this set as A. Okay. So now I have made a new state called as A here. So now we will have to apply all the inputs in A. So inputs, two inputs are there, that is A and B. So delta dash of A comma A is equal to epsilon closure delta of, and what is A? A is actually Q1, Q2, Q4 and Q6, and I apply input A. So this is equivalent to epsilon closure delta of Q1 comma A union Q2 comma A union Q4 comma A and union Q6 comma A. Okay, so union Q6 comma A. Now the problem is when you apply A, the only possibility A can be applied only in Q2. Okay, so Q1 you cannot apply A, Q4 you cannot apply A, and similarly Q6 also you cannot apply A. So only possibility is Q2 here. Okay, when A is applied in Q2, it goes to the state called as Q3. So you just get, rest of the things are pi. So epsilon closure for Q3 is equal to, so what is the answer? Q3, it goes to, Q3 goes to Q6, Q6 goes to Q1, Q2 and Q4. Okay, so the answer is Q1, Q2, Q4, sorry Q3, Q4 and Q6. Okay, so name the state as B here. Okay, so when I apply A, it actually you are getting a new state called as B. Okay, in A. But now I have applied only A here, so now I have to apply B. So delta dash of A comma B is equal to epsilon closure. So delta of Q1 comma Q2 comma Q4 comma Q6 B. Okay, so where B can be applied? Only in Q4 I can apply B. Rest of the things I will generate pi only. Okay, only in Q4 I can apply B. So epsilon closure delta of Q4 comma B. So when I just apply Q4 comma B, Q4 B actually it goes to Q5. So epsilon closure of Q5. Okay, epsilon closure for Q5 actually it goes to Q5, Q6, Q1, Q2 and Q4. So Q1, Q2, Q4, Q5 and Q6. Okay, so this is not the same state which we have generated in B. There actually I have Q3 but Q4 does not exist over here. Definitely it's going to be a new state. So this is going to be the state called as C here. Okay. So now I think all these states we are going to identify this. Now I have applied A and B. Now I am going to apply B here in for delta dash. So delta dash B comma A is equal to epsilon closure delta of, and what is B? So B is actually Q1 comma Q2 comma Q3 comma Q4 comma Q6 and I apply B here. Okay, so where actually B can be applied? The only possibility B can be it is A, isn't it? So it is A now. The only possibility is A can be applied only in Q2 and the rest of the things you cannot apply A here. So when I apply A in Q2, it goes to Q3. So as per the transition diagram, it goes to Q3. So again, I just get epsilon closure of Q3. And what is epsilon closure of Q3? We already have an answer for epsilon closure of Q3, that is B. Okay. So epsilon closure for Q3 is equivalent to B here. Okay. So it is not generating a new state. Now delta dash of B comma B is equal to, so epsilon closure delta of Q1 comma Q2 comma Q3 comma Q4 comma Q6 comma B. Okay, so where B can be applied? The only possibility is B can be applied in Q4. Okay, so Q4 is here, Q4 is here, so Q4 when I apply B, it goes to Q5. So epsilon closure of Q5. So epsilon closure for Q5, you get the answer called as same answer which is already there. So epsilon closure for Q5, you actually get the answer called as C. So just go and just mention epsilon closure for Q5 is actually C here. Okay, so B I have applied and now I am going to apply for C. So delta dash for C comma A is equal to, so epsilon closure delta of what is C? It is Q1 comma Q2 comma Q4, Q1 comma Q2 comma Q4, Q5 and Q6 comma A. Okay, so it can be applied on only Q2, so automatically epsilon closure of Q2, when I apply A, it goes to Q3. So the Q3 is actually epsilon closure for Q3 is already identified. It is called as B. Now no new state is again generated, so C comma B here. So epsilon closure for delta of Q1 comma Q2 comma Q4 Q5 comma Q6 comma B. Okay, when I apply Q6 comma B, where actually this when you apply B here, the possibility is only in Q4 I can apply B. So if I apply B in Q4, it goes to Q5. So answer is epsilon closure for Q5 is equal to your epsilon closure of Q5 actually generates C here. Okay, which is already there. So that's it. No new state is getting generated, but we will construct a table here. So how to construct a table for this? So now I have 3 different states. One is A here, A, another is B, another is C here, and the inputs are A and B. So this is going to be the DFA table. So when I apply A in A, it actually generates B. When I apply A in B, it actually generates C. Okay. When I apply B in A, it actually generates B. And when I apply B in B, it generates C. It generates C. And when I apply C in A, again it generates B. And when I apply B in C, again it generates C. Okay. But automatically A becomes the initial state. So why A becomes the initial state? Now, what is the original diagram? What is the initial state? An initial state is actually Q1 is called as an initial state, where Q1 exists in A, so automatically the first state A will become an initial state. But what is the final state here? So the original diagram Q6 is in the final state. So wherever Q6 exists, everything should be the final state. So Q6 exists in A. And you can see here Q6 also exists in B. Q6 exists in B. And you can see that Q6 also exists in C. Okay, so all these states are final states. So star, star, star. Okay. And now you are supposed to draw the diagram. So A. So this is going to be the final state. B, this is going to be another final state, and C, this is going to be another final state. So make A as initial state. So when I apply A, it goes to B. When I apply B, it goes to C. And when A is applied, it goes to B itself. And when B is applied, it goes to C. And in C, when I apply A, it goes to B here. And in C, when I apply B, it goes to C itself. Okay, so B. That's it. Okay, so thanks for watching the video. Have a good day.